Can you remember an event in your life that further down the road made a significant impact on your career? Who can remember a time like that? Big time that turned around everything for you? Go once again? Yes. Anyone? Awesome. If you were with me on July 25th, 2015, you'd be enjoying the sun and the sound of waves on a beautiful sandy beach, the one that you wouldn't quite expect to find here in the south of England. I've just finished a 4-day kitesurfing course, 0 to hero. I'm keen to continue doing kitesurfing, so I come to a local kitesurfing shop to purchase my first wetsuit. I come to the till. I'm way too excited about my purchase to pay much attention to the fact that instead of asking me to insert my card into the payment device, the guy at the till takes my card and starts entering the card number on his website. That's how I paid for my purchase. The following day at home, I get a phone call from my bank. A lady on the phone asks me to confirm my purchases, like Amazon for £100, Netflix for £20, and I don't quite remember making those purchases. I jump into my car, I drive to the local police office. I want to help the police catch the fraudster because I know who he is. But the police officer just hands me a leaflet and asks me to go to a website to report my fraud over there. Due to the large volume of card fraud, the police don't have capacity to deal with it. Little did I know back then that globally fraudsters steal millions per day, billions per month. But for me, it was that feeling as if someone got into my pocket and stole money from me. It haunted me for quite a while. We're now in April 2016, the year when the world starts to talk louder about machine learning and artificial intelligence. It's the year when DeepMind's AlphaGo beat Lee Sedol in the game of Go. It's the year when Google launched their machine learning platform. I get excited by the opportunities that AI opens up, so I sign up to a number of courses on Coursera and Udacity. Sorry. Second. And to my surprise, in about a year, I finished them all. And perhaps it was this note that I put on my wall, saying I want to change the world and improve people's lives through the application of AI algorithms that pushed me forward. We are now in June 2017, the year when I discover Revolut. Revolut, founded by Nick and Vlad. I fall in love with this idea of a global mobile bank. You see, at Revolut, in everything we do, we aim to redefine what's possible. We see the world without borders, without barriers, neither on the ground nor in people's minds. At Revolut, our mission is to build a global mobile-first bank for all your financial needs, be it current accounts and credit cards, mortgages, loans or investments, or insurance. On a Skype interview with Nick asks me if I would like to help Revolut protect their customers from card fraud. And remember those flashback moments we see in movies? I immediately say yes, because I want revenge. I want to show fraudsters we can protect ourselves. 9 months after joining Revolut, I developed Sherlock. What is Sherlock? Well, Sherlock is a machine learning-based fraud detective that continuously monitors your card transactions, and when it notices a suspicious one, at that very moment, in under 50 milliseconds, it sends you a push notification asking you to confirm if it's actually you who makes that transaction or not. And you can give Sherlock a response. If you say that no, it wasn't you, your card gets terminated and you can order a free replacement. If you say that it was actually you, your card gets unfrozen and you simply repeat the purchase. Now, what's just recently dawned on me is that compared with other established high street banks who have a whole department with hundreds of people on the phone calling their clients to confirm suspicious card transactions, at Revolut, While, of course, we do have the chargebacks team who handle fraud cases reported by users. There is no one but Sherlock who monitors card transactions, and we delegated the responsibility for confirming suspicious card transactions to our users. Now, to help you understand our thinking and how we actually built Sherlock, we put our experience into a framework which we call the Data-Driven Development Framework. It consists of 5 elements: define, discover, design, develop, and deploy. So let's dive deep into it. At first, we start with defining a problem. And what I mean by that is that we have to formalize our business problem in terms of a machine learning problem. In our case, we wanted to detect fraudulent card transactions. But essentially, what we are trying to predict, if we think a bit deeper, is not so much the fraud, because we cannot catch all fraud. Some fraud gets unreported. What we want to predict, essentially, is whether for a given transaction, a user will come to our support chat and report it as fraudulent. And our support team will have to refund it. That's essentially what we are trying to predict. The second element that we have to define is how we evaluate the performance of our system. Here we define the metrics. And at a first glance, since we might interpret this problem as a binary classification problem, we might come up with such metrics as precision, recall, false positive rate. But once again, if we think a bit deeper, we will discover that it is much more beneficial to catch the first instance of fraud in the sequence of fraudulent transactions, which helps us create additional metrics with the help of which we tune the performance of our algorithm even further. Finally, we define the talent that we will need to solve this problem. In our case, we wanted such talents as data wrangling, data analysis, project management. But in the realities of a startup, one person can wear multiple hats. We then move on to the discovery stage, where we look for the labels for our data. Now, because we are going to solve our business problem with the help of supervised machine learning. Now here I'm very grateful to our chargebacks team, who since the early days have been capturing fraud cases reported by users in a very accurate format in our database. That was something that contributed significantly to the success of Sherlock in the early days. We then move on to discovering the data that we're going to need to solve our problem. And here we pay attention to data quality, because in the end we know garbage in, garbage out, and the financial data is usually very, very messy. And also we perform some initial data analysis over here, for example, to see if there is any correlation between the time of day and when the fraud happens. And finally, we visualize our findings and perform some initial hypothesis testing. We then move on to the design stage, where we start with designing the architecture of our solution. Now, the peculiarity of financial card transactions lies in the fact that their state can change over time. For example, a transaction can get reversed, or a user might request a refund. As a result, we built what's called Lambda architecture, consisting both of online processing, or real-time processing, and nightly batch processing aimed at fixing any inconsistencies that happen throughout online processing. We then look at the user interface and user experience. Since we, as I mentioned, wanted to delegate the responsibility of confirming fraud transactions to our users, we had to think how to design screens in such a way to feel user at ease when he receives such a push notification, but also give them a nice and convenient way to give feedback. Finally, we think how we're going to integrate our solution with our processing backend. And the way we did it is that Sherlock is some kind of like a third-party transaction monitoring service. And what I mean by that is that for the processing backend, Sherlock is just a black box. It sends a transaction and receives either 1 or 0. We then move on to the development stage, where we take into account, first of all, the language that we're going to use for research and development. Now, some companies use one language during research, For example, because Python is so much more common in the data science community, and then they use some kind of a more performant language in production. Now, we decided to stick with Python both in development and in production because it allowed us to move much faster and reduce the possibility of any inconsistencies that happen that could have happened when we would rewrite the code for production. We then work on perhaps the most challenging part when solving any business problem with machine learning. We work on feature engineering. It's the process that requires the most creativity, and that's what I love the most about it. And what are features? Features are those data elements that serve as input to a machine learning algorithm. And here, if we face the problem of generating those features for millions of users, we want to use something that can parallelize the code very easily. And here we employed Apache Beam running on Google Cloud Dataflow. Finally, we research the algorithm that we're going to use in production for our model. We started with linear models to establish some kind of a baseline. We experimented with support vector machines. We played with neural networks. In the end, we saw the benefit of using gradient boosting on decision trees with the implementation from a library, an open source library called CatBoost from a company called Yandex. And just to help you understand the feature engineering logic, let me illustrate it with the following typical fraud case that we observe. So we start with looking at the first row. We see that this user went to India, where she used taxi, and she paid for her trip using Maxstripe, the last column. After a few days, she comes back to the UK, where she buys something at the airport cafe using chip and pin, the second row. In a few days, she notices fraudulent transactions on her account. So what essentially happened is when she paid for her trip using Maxstripe, her card information got cloned, and by the way, Maxstripe is that black stripe on the back of your card. So her card information got cloned, and fraudsters simply implemented a copy of her card and then used it to withdraw cash. Now, over here, we can see why it is much more beneficial to prevent the first instance of fraud. We can save much more money than if we tuned our algorithm to catch the third or the fourth instance of fraud if we implement one of our features to consider velocity of those transactions. Now what are the features that we are using to predict for a given transaction if it's fraudulent or not? We of course start with very basic features, with simple features that require minimum or even no pre-processing, such as merchant name, the amount of the transaction, currency, and the country. But the most interesting part is designing complex features. We start with features that are user-focused. And what I mean by that, these features take into account the user's previous purchasing behavior. And what I mean by that is that for a given transaction, we ask by how much your current purchase is different compared to your previous purchases at this merchant at this time of day. We then move on to developing merchant-focused features, where we take into account the merchants, the behavior that Revolut users exposed with a given merchant. And here we ask similar questions, like, for example, by how much your purchase, say, with Amazon, is different compared with how much Revolut population spends with Amazon on average on a daily basis. Now, here we have two problems. At first, we need to generate the training data in such a way so that it would imitate the production as close as possible. And what I mean by that is that when we generate our features, we cannot look at the transactions that happened before the current one. We can only look at the transactions and take into account only the ones that happened before. We only take into account the transactions that happened before the current one. And secondly, we want to generate user and merchant profiles containing data elements that will help us in real time, given an input transaction and the corresponding user's profile, to construct the feature vector as similar as possible. Well, of course, exactly the same feature vector as we used during training. And we have to be able to quickly regenerate user and merchant profiles, as I mentioned, because we run this process every night to fix any inconsistencies that happen throughout the day. Now, if you take into account that as of today, Revolut is over 8 million customers strong, and this number grows about 1 million customers per month, we wanted to find a way to quickly generate these profiles and parallelize the creation of these profiles per user. And we solved this problem, as I mentioned, using Apache Beam and Google Cloud Dataflow, which Apache Beam is a framework that allowed us to focus on the business logic of various transforms that we perform on our data. Now, let's move on to the final stage, deployment, where we take into account how we're going to orchestrate our solution. And we leveraged Google Cloud Composer, which is essentially a managed version of Apache Airflow. We then think how to make our service resilient, because in the end, Sherlock is a mission-critical application. And we achieved that using Google Cloud App Engine, which is essentially a managed service for Kubernetes, and Couchbase, the in-memory database that we use for storing customer and user profiles. Finally, we need to think how we're going to monitor our solution, and we achieve that using stack driver alerts and for technical indicators like CPU usage, like memory usage, and Kibana, where we visualize in real time the performance of our model, such as precision, recall, and false positive rates. Now, to help you understand what's underneath Sherlock, let's review the architecture. Now, as I mentioned, it consists of two elements: the nightly batch and the real-time processing. If we look at the bottom left corner, it all starts with getting the delta dump of transactions from our transactional database called Postgres, and we dump those transactions into BigQuery. We then run a number of Google Cloud Dataflow jobs that take this data from BigQuery and regenerate user profiles. The user and merchant profiles are then dumped into Couchbase, which is running on Google Compute Engine. And we generate the training data that is dumped again onto BigQuery over here. And this data is then used by a number of machine learning jobs running on Google Cloud ML Engine, where we train CatBoost. The model is then dumped onto Google Cloud Storage, somewhere in the top right corner. And then in real time, when you make a transaction with your Revolut card, our processing backend sends this transaction to Sherlock app deployed on App Engine. In this very moment, for the given user, for the given merchant, Sherlock takes the corresponding user and merchant profile from Couchbase, creates the feature vector, applies the model that is deployed in memory, and issues the prediction back to the processing backend. I could talk for hours about individual elements on this diagram, but today let's focus on perhaps the most important one: how we generate user and merchant profiles and why we chose Couchbase. Now we always start with the requirements for our profile storage. And for us, we wanted this schema to be as flexible as possible to account for any future features that we would develop for our users. And that's why we decided to store them as JSON documents. We wanted the database to support SQL so that we would be able to debug our user and merchant profiles and perform some analytics. We wanted it to be a key value storage so that for a given user ID or merchant ID, we would quickly retrieve the corresponding user profile or merchant profile. We wanted it to respond with single-digit millisecond latency because of the overall time limit imposed on Sherlock. We wanted it to be, we wanted to support high throughput, be highly available, and very critical to be very easy to maintain. Now, I admit Couchbase wasn't our first choice. We were quite lazy enough, and we opted to go for Google Cloud Data Store, despite the benefit of having of it being a managed NoSQL database. The latencies we experienced from it was just far from perfect. We experienced something like 200 milliseconds to retrieve a single user profile, and the overall time limit on Sherlock is 200 milliseconds. Now, how we deployed Couchbase at Revolut. The convenience of deploying Couchbase lies in the fact that they made it available through Google Cloud Marketplace, which allowed me to deploy our 10-node cluster by clicking just a few buttons. So by far, it was not much more difficult than using Google Cloud Data Store. What I love about Couchbase is the fact that we can segregate the duties of individual nodes. For example, in our setup of just 10 nodes, we have 8 data nodes. So 8 data nodes that are that serve specifically the user and merchant profiles. 1 node for querying and 1 node for indexing. Overall, as of today, we have around 40 million documents that store both user and merchant profiles. Each document has got three replicas, so that in a rare event of one of the nodes going down, Couchbase could quickly switch to another node with available replica. And that's what actually helped us to make the service so resilient and not experience pretty much any downtime, because we just can't have those. As of today, Couchbase serves both Sherlock and other fraud-related models. And we experience something around 300 operations per second, peaking up to 8,000 operations per second at those nightly events when we regenerate user and merchant profiles. And taking into account that, as I mentioned, Revolut grows at a pace of over 1 million customers per month, we expect that to double in about a year. And the convenience is that I would just have to go and deploy one more node, also through Google Cloud Marketplace, add it to the cluster, and then rebalance everything. Rebalance the data so that it would be able to support higher throughput. As of today, we experience the latencies of around 3 milliseconds, the 99th percentile, to retrieve user and merchant profile. And it's maintained by one person. And I urge you guys to go and talk to Couchbase. I think their logo is very visible over there at stand number 139. If you are working on any fraud detection project or any project requiring highly personalized solution, I don't know if there is any better solution if one of your requirements is also to be mission critical. Now, this is a graph representation of I wonder if it's going to play. No, it's not going to play. That was a graph representation of a job that generates merchant profiles. Every box in this diagram is some kind of a cleanup or a statistical operation on a given merchant. And these profiles get dumped into Couchbase. Now, oh yeah, now it works. So anyway, so it gets really beautiful down the bottom, which actually illustrates how we can parallelize the generation of these user features per millions of merchants that we have at Revolut. And yeah, as I mentioned, at the bottom we will see the input into Couchbase, where we see such rates as over 8,000 operations per second. Now, this is something that we have never shared before, but the fact that Sherlock has been in production for over a year made us much more confident in sharing these performance metrics. In this graph, we see the fraud rate, the percentage of fraud in the total volume of processed card transactions. As I mentioned, Sherlock was deployed about over a year ago, so somewhere in this area. you can see that before Sherlock, we had fraud rates of around 3 to 4 basis points, which was already lower than the industry average. After we deployed Sherlock, especially in the last few months, we have observed fraud rate of less than 1 basis point. To be clear, that's less than 1 cent is lost per $100 processed. This is what this metric allows us to say that we are 6 to 8 times more effective than the industry. According to the recent FCA report, the industry average fraud rate is around 6 to 8 basis points. About 96% of fraudulent transactions get caught, which results in about, the lower estimate is around 75 to 85% of United States dollars being saved, which boils down to around 300 to 400,000 dollars saved every month. Our false positive rate is below 10 basis points. By the way, one basis point is 0.01%, which means that 10 basis points is 0.1%, which means that in the total volume of legitimate card transactions, less than 0.1% get blocked by Sherlock incorrectly. And if you receive a push notification from Sherlock, then the probability that Sherlock is right is around 25–30%. Now, I prefer a more entertaining way to look at these metrics. For instance, this is a dashboard which I built in Canvas as part of the Kibana. And this was quite a productive day for Sherlock. It saved over 14K on that day. And my goal is to make this unicorn as pink as possible, which reflects the precision of Sherlock. So as you can see, there is still some work to do. Now, what are the takeaways? First of all, pay attention to your data quality. If you are thinking about a business process that you might automate in the future, start paying attention to data quality as early as possible. Make it a priority for your employees, or if you work for a company, make sure that you pay as much attention as possible to how you input the data. Secondly, start implementing machine learning algorithms as early as possible into your processes. When I joined Revolut and ran a simple query, I saw only 2,000 transactions that were compromised in a whole sea of millions of cards. As you can imagine, it was like trying to find a needle in a haystack. But the fact that we deployed Sherlock quite early, in those early days, we observed the recall of around 40%. That is, only about 40% of USD dollars were saved with the help of Sherlock. But the fact that we deployed it early into production and implemented such direct feedback from our users gave us high-quality data, and as a result, the performance of Sherlock just keeps improving. Thirdly, embrace the cloud. When I think about Google Cloud, it reminds me of Lego. And I used to love to play Lego when I was a kid. I could build anything from castles to cars using those same building blocks. Today, I build systems using the blocks represented by Google Cloud Services, which are expanded by the services available through Google Cloud Marketplace. Finally, experiment. Ask more what-if questions. Like, what if I try this and it works? Be curious. This is the advice that I can give to you. When I joined Revolut, I simply created a new project in our Google Cloud. I came up to our CTO and asked him to attach the billing account. At that moment, I realized I have like infinite power. And yeah, so keep experimenting, keep asking yourself such questions as, what if I try this and it does work? Finally, perhaps the most exciting part about working on Sherlock is seeing the effect that it makes on our customers. For example, this is just a few tweets. The one saying, "Thank you, Revolut app. Somehow my old card was compromised. you automatically stop the fraudulent attempt to withdraw £500 somewhere in the USA. You see, I believe, guys, that we are living in remarkable times when enormous computing power, data processing, and the talent of world-class engineers is literally at our fingertips. We are only limited by our imagination and the ability to uncover problems worth solving. So what will you solve next? My name is Dmitri Lahhatsov. Thank you very much.